We're going to be going through the editorial solution because I don't really enjoy solving binary questions, but the solution is really unique and really beautiful to look at. So let's dissect it one by one. It says given two numbers, number one, number two, find a positive integer x such as x has the same number of bits as num2. So set bits. So basically the number of ones in x, whichever number is going to be generated, has to be the same number of ones in num2. And the value of x XOR num1 is minimal. So if we take num1, XOR it with x, so basically 0 XOR 1 or 1 XOR 0 is 1, otherwise it's going to be 0, is minimal, right? Return integer x, right? It starts off, the solution really is intelligent. Like I love how they solve it. I could never solve it by myself, but it's really something to look at. Um, let's see result. He starts off initializing the result to num1. If num1 got XOR'd to num1, what's the answer, right? The answer is gonna be 0 because they all identically the same, right? So the answer is gonna be 0. So it's gonna, what's it gonna do is it's gonna try and generate a number from num1. Maybe that number might have more set ones than num1, and it might have less set ones. So basically, there's going to be a target of set bits, which is going to be the number of ones in num2. Currently, I have num1. I might have more ones, and I might have less ones. Either or, that's what we're going to try and adjust, right? But you have to remember that we start at num1, right? And then this is the index of the current bit, basically. So we're going to start from the right, least significant bit, which is the right side. We're going to start from the least significant bit, right? What we do is we're going to check, do we have less than the target or do we have more than the target? So basically, when this code executes, it might go in here, or it might go, or it might go in here, right? Either or, what happens is, if we have less bits, we need more ones in our answer, right? We need more ones in our answer. That means when going, it starts from index 0, right? What it does is it checks if that current bit is set in result, if it's set to 1. Because if it's set to 1, I can't do anything. I got to move forward and find a 0 to set it to 1 because we have less ones. We need more ones, right? So what happens is, if it's not set, basically, it sets it and it increments the bit count. So it sets it to 1, meaning that the current result, which initially was number 1, like the first number, got altered, and a 0 has became a 1. So if we XOR that with number 1, like the original number, that bit is going to be counted in the final answer, basically, because now there's difference between them, between the original one and now because we altered it. What does set bit do? Set bit basically, it moves, it starts off with a 1, a single 1, and it moves it, it left shifts it bit times, which is the bit count, like the index I'm at, current bit. It sets it, it moves it, and then when it moves it, it ORs it with the x. So basically any 1 in an OR operation is going to be 1 anyways. So that's what it does. This I love this. This is really, really interesting to look at. Anyways, it keeps doing this. It keeps incrementing until we find until this is valid, right? So basically, from the right side, it gives priority to increment adding ones from the right side, because if there is ones on the right side, having them XOR'd with zeros is beneficial because the right side is always smaller. Now comes the other case. What if the set bits count? What if we chose a number? What if num1 has more ones than the target? Now that means we need to remove ones. We need to remove some ones, right? And removing ones is going to be literally the same operation, starting from the rightmost side, right? If it's set, just unset it, and when you unset it, you now made a difference. Like there's now a 0 and a 1. XOR'd gives us a 1. So unsetting from the right side also is beneficial because it also is going to give us a less number overall, right? And then it keeps going, and then it keeps going, and then it keeps going. But now you decrement until you match. And then in the end, you're just going to return the result. basically. So yeah, unsetting a bit is interesting too because you move the one bit times, as I said, and then you knot it. Like this is a knot operator. So it's the one is going to be a zero basically, and then you AND it with the x. So that index is going to get zeroed anyways, right? Yeah. So that's been it for this question, guys. Thank you for watching, and see you in the next one.